You guys are on text page 170. Matthew, move that over a little. And blue notebook page 162. So we skipped lesson 3.5. It is very similar to what we were doing yesterday, just solving word problems using quadratic factoring. So today we're going to solve making quadratic expressions from data. Okay? So you guys are going to define these two terms, curve a good fit or best fit, and quadratic regression. I want you guys to look at example 1 in your textbook. So that's on page 171. The next page over. Okay, example 1. If you guys look at our graph, we have no equation for this, okay? But we do have some information. First off, they've given us the vertex, -1 and 24. I don't have a y-intercept, though it looks like I could probably guess. I don't know exactly where the point is. Could be a decimal, so we're not going to make an inference about that. We're just going to leave it for now. We have a vertex, and they've given us our 2 zeros, okay? One of them is at 0. Oh, sorry, I wrote that backwards. 2 and 0. And the other one is at -5 and 0. So I have 3 points on this graph right now. They're asking me in the question to make a quadratic expression. Okay? So I have the zeros, but I have no idea how to put that into the form we're used to. We're used to seeing our expressions in standard form. So we have our x squared, x plus, and we'll write our letters in. We're used to seeing ax squared plus bx plus c. Okay? Now, from the information I have, I am unable to just plug numbers in for A, B, and C. I'm going to have to work backwards. And we're going to work backwards from our factoring. Okay? So you guys remember around the beginning of this chapter, they gave us an equation that looked like this. It had our y or f at x or h at x, depending what they use. We'll say y for now. Y is equal to, they gave us an A, x minus r, x minus s. Okay? So they've given us this equation. This was essentially our factored form. For the last chapter, we'd been working on going from our standard form here, ax plus bx plus c, and we'd factor the expression, so our a would be the common factor we find, if there is one, and our r and s would be our zeros. Right now, I have no numbers in my standard form or my factored form, but I do have a graph. From this graph, I can plug information into the factored form, then expand and simplify to get into my standard form. So, first off, what I'm going to do is I'm going to plug in my zeros. R and S are going to represent what our zeros are. Okay? So, what that means, the next line, I'm going to write in y is equal to A, x minus, now our first zero, we'll do them in red just so you guys get used to seeing that. Our first zero is -5, so I plug in -5. That's going in place of the r. Yeah, it's going to be, but I'm going to show you how we start it. Next one, we have s, subtract, and our other zero was 2. So we plug in the number 2, which goes in place of that s there. And we end the bracket. Sorry that's so far to the side. Okay? So all I've done is replaced my r and my s, so both of my x-intercepts, or my zeros, with their x-coordinates. In this case, we had a 2 and a -5. So I've plugged those in. I'm going to simplify that. Y equals A. This becomes x plus 5. And this becomes x minus 2. Okay. So I've got 2 numbers now, but I still have x as a variable, y as a variable, and a as a variable. I don't have enough information to get actual numbers for my a, b, and c in my standard form. Luckily, they've given us the vertex. Now, the vertex is giving us 2 points. It's giving us an x-coordinate and a y-coordinate. Well, in our equation here, I have a y, so I can plug in the information for that. And I have 2 x's. In fact, these are the exact same x, okay? So whatever I plug in as a value for one of them, I plug in for the value of the other. So in this case, our y is 24, and both of our x's are going to be -1. So we're going to plug that into our equation now. So for my y, I should write that in red. My y, like we said, is 24 is equal to a. Still have no idea what a is. X is -1. So we plug -1 in for our x, plus 5. Our other x, we plug the exact same number in, okay? These both represent the same number. -1 again. Oh, make sure I get the bracket there. -2. Okay? From here, we're going to simplify and then talk about what our next step is. So I still have 24 is equal to a. This becomes -1 plus 5. This becomes -1 subtract 2. So now what's happened is I've replaced our y's, our x. Here, I'll underline them so you guys see what we're doing. I've replaced a y value with a number. I've replaced both x values with a number, and we've replaced our r and our s with a value. What that means is I'm only left to solve for one variable right now. I need to solve for a. That's what we're looking for. Okay? So now that I have all these numbers, all I have to do is simplify. I need to isolate a to get it by itself on one side. So what's going to happen is I'm just going to simplify our brackets. We have 24 is equal to a. -1 plus 5 is 4. -1 subtract 2 is -3. This here, I know that looks like a 9. That's supposed to be an a. A times 4 times -3. Let's extend this page. This becomes 24 is equal to, well, I can multiply the a times 4. It's going to be 4a, and times -3 is going to be -12a. So all I did was multiply 4 times -3, -12a. Now, like we said before, we're trying to isolate a, so I need to get the -12 to the other side. And to do so, I'm going to divide both sides by -12. A is going to equal what? -2. Okay. So I solved for my a, but I still don't have what we were looking for in the original. We're looking for an equation that looks like this. Our ax squared plus bx plus c. We're looking for an equation like that. Circle it just so you guys have an idea what I'm talking about. Okay, we're looking for something that looks like that. So now that I have a value for a, I go back to my factored form. Okay, we're going to go back to our factored form, and we're going to plug in the values we had from before. We had our two zeros, -5 and -2, and this time I'm going to plug in a value for a. I'm going to leave y and x in their variable form. So our very next line, like we said, here's our factored form. Go back to our factored form, which was y is equal to a, x minus, what did I say, r first? Doesn't really matter, x minus s. I have a value for a, it's -2. So I plug in -2 for our a. X minus, one of our zeros was -5. X minus, our other zero was +2. Okay, so what's happened now, if you guys notice, I plugged the value in for a, it's -2. I plugged the value in for r, which is -5. That was one of our zeros on the graph. That's how we found that. And a value for s, which was +2. Now that I've done all of this, I just want to expand and simplify. So here we go. Y is equal to, we have our -2. This becomes x plus 5. This becomes x minus 2. Okay? These two here in our brackets, I'm going to FOIL. Okay? These two brackets right here, I'm going to FOIL them first. I'm going to leave my negative 2 out for now. I'm going to FOIL and then bring the 2 in after. So we get y is equal to negative 2. When I go to FOIL this expression, x times x is x squared. X times negative 2, 2x. 5 times x, positive 5x. And 5 times negative 2 is 10. And move quickly here, okay? Negative 2, x squared plus 3x minus 10. And finally, I bring the negative 2 in. So I distribute it to every number inside the brackets. I get negative 2x squared minus 6x plus 20. Now, if we take a look at this, I have an equation that looks very similar to our standard form. I have a value for A, negative 2. I have a value for B, negative 6. And I have a value for C, positive 20. We get that plus sign in there. Okay?